There's a marine mechanic in Florida who's been fixing outboards for 42 years. He's worked on over 8,000 engines, and he told me something that manufacturers don't want you to hear. Everything they tell you to do shortens your engine's life. These are the tricks that void your warranty, the ones that break the rules, the practices that dealers will never put in writing. And yet, the engines running on these forbidden methods outlast factory-maintained motors by thousands of hours. So why are the tricks that actually work the ones you're not supposed to use? Today, we're pulling back the curtain. 10 practices the marine industry doesn't want on record, and the engineering reasons they might actually work. Every year, millions of outboard engines roll off assembly lines in Japan, Belgium, and the United States. They arrive wrapped in plastic, gleaming with promise, and backed by warranties that read like sacred contracts. Mercury, Yamaha, Suzuki, Honda. These names carry weight. They represent decades of engineering, billions in research, and marketing campaigns designed to make you believe one simple truth: follow the book, and your engine will last. The modern outboard is a marvel of precision. Computerized fuel injection, corrosion-resistant alloys, sealed power heads that promise 3,000 hours of trouble-free operation. When you buy one, you're not just buying an engine. You're buying into a system, a maintenance schedule, a network of authorized dealers, a specific brand of oil that costs $32 a quart. And the message is clear: use their parts, trust their technicians, follow their intervals, deviate from the plan, and you're on your own. It sounds reasonable. These companies employ thousands of engineers. They test their products in labs and oceans and torture chambers designed to simulate a decade of abuse in a single month. Who are we to question their expertise? But here's what the brochures don't mention. The annual cost of manufacturer-recommended maintenance on a 300 horsepower outboard runs between $1,200 and $2,400. That's dealer labor, factory filters, branded lubricants, and the peace of mind that comes with a stamped service record. Miss one appointment, use one unapproved product, and that extended warranty you paid $2,000 for becomes worthless. This is the warranty trap. And it's not an accident. Manufacturers don't just sell engines. They sell parts. They sell service. They sell the replacement engine you'll need when your current one reaches the end of its designed lifespan. Every maintenance visit is revenue. Every proprietary filter is margin. Every engine that fails at 4,000 hours instead of 8,000 is a future sale. This isn't conspiracy. It's business. And once you understand the incentives, the maintenance manual starts to read a little differently. But something else has been happening in marinas and boatyards for decades. A different kind of knowledge has been passed down, mechanic to mechanic, captain to captain. These aren't trade secrets published in service bulletins. They're practices learned through trial and error, through thousands of hours on the water, through the hard education of engines that failed and engines that refuse to die. Some of these practices void warranties. Some violate EPA regulations. Some would make a factory engineer shake his head in disbelief. And yet, the engines running on these forbidden methods consistently outlast their factory-maintained counterparts. In commercial fishing fleets from Alaska to the Gulf of Mexico, you'll find outboards with 12,000 hours on the clock. Twice the expected lifespan. 3 times what the warranty promised. And when you ask their operators what they're doing differently, they'll tell you things that would never appear in an owner's manual. They'll tell you about fuel additives that manufacturers forbid, about oils that cost half as much and protect twice as well, about thermostat swaps and idle adjustments, and flushing techniques that service advisors have never heard of. They'll tell you about the tricks that actually work. The first one involves something you can buy at any auto parts store for $8. It's been around since 1923. Pilots used it in World War II. Classic car collectors swear by it. And if you add it to your outboard's fuel tank, your dealer will void your warranty on the spot. It's called Marvel Mystery Oil, and what it does inside a modern 4-stroke outboard is something manufacturers don't want to talk about. To understand why Marvel Mystery Oil matters, you need to understand what changed inside outboard engines over the past 20 years. The old carbureted two-strokes were simple machines. Fuel and oil mixed together, flowed through the intake, washed over the valves, and burned in the cylinder. It was inefficient, it was dirty, and it left a protective film on every internal surface the mixture touched. Modern four-stroke outboards are different. They're cleaner, more powerful, and far more sophisticated. Direct injection systems spray fuel straight into the combustion chamber at pressures exceeding 2,000 psi. The intake valves never see fuel. They never get that protective wash. And over time, carbon deposits build up on surfaces that were never designed to run dry. This isn't a design flaw, it's a trade-off. The same technology that makes modern outboards more fuel efficient and EPA compliant also creates a maintenance problem that manufacturers rarely discuss. The solution has been hiding in plain sight for a century. Adding a small amount of light oil to gasoline restores the upper cylinder lubrication that direct injection eliminated. 2 ounces per 10 gallons. That's all it takes. The oil vaporizes with the fuel, coats the intake valves, and prevents the carbon accumulation that leads to poor sealing, rough idle, and eventual valve failure. A charter captain out of Islamorada has been running this formula in his twin Yamaha F300s for over 4,000 hours. 0 carbon issues. His neighbor followed the factory maintenance schedule to the letter and needed valve service at 1,800 hours. The only difference was $8 worth of Marvel Mystery Oil per tank. General Motors engineers quietly recommended the same approach for certain direct injection automotive engines facing identical problems. But you won't find that advice in any marine owner's manual, because admitting the problem exists would raise questions manufacturers don't want to answer. The second trick lives below the waterline, in the part of your outboard that spends its life submerged in salt, sand, and whatever else floats in your local waters. Your lower unit is a gearbox. It contains a drive shaft, a set of precision gears, and bearings that spin thousands of times per minute while fighting the resistance of a propeller pushing against water. The oil inside that gearbox is the only thing standing between smooth operation and catastrophic failure. Manufacturers want you to use their oil. Mercury High Performance Gear Lube, Yamaha Yamalube, Suzuki X-Star. These products cost between $28 and $45 per quart. And for what they are, that's difficult to justify. Most factory lower unit oils are conventional or semi-synthetic formulations. They work. But they don't outperform premium synthetic gear oils that cost a third of the price. Mobil 1 Synthetic Gear Oil, Royal Purple Max Gear, Amsoil Severe Gear. These products offer superior shear stability, better water separation, and thermal performance that exceeds what most marine manufacturers specify. They're designed for differentials and transfer cases that experience similar loads and environments. And they carry a GL5 rating that meets or exceeds marine requirements. A commercial shrimper out of Louisiana runs 12,000 hours between lower unit rebuilds. His dealer told him to expect 6,000. He's never once used factory oil. The engineering is straightforward. Synthetic base stocks resist breakdown under pressure. Advanced additive packages neutralize acids and suspend contaminants. The proprietary formulations that justify marine pricing are often less advanced than what you can buy at AutoZone. But here's what makes this trick truly forbidden. Using non-OEM oil doesn't just save you money. It exposes a pricing structure built on captive customers and warranty anxiety. And that's something the industry would rather you never figured out. The third trick requires a $20 part and a willingness to question why your engine runs as hot as it does. Your outboard engine runs hot by design. Factory thermostats on most modern outboards open between 156 and 163 degrees Fahrenheit. That temperature isn't chosen for longevity. It's chosen for emissions compliance. Hotter combustion burns fuel more completely. It reduces hydrocarbon output and helps manufacturers meet EPA certification standards. But heat is the enemy of mechanical systems. It accelerates wear on cylinder walls. It degrades lubricants faster. It stresses gaskets and seals that were never meant to operate at the edge of their thermal limits. The fix is simple: a lower temperature thermostat that opens at 143 degrees instead of 160. The part costs less than a tank of gas. The installation takes 30 minutes, and the benefits accumulate over thousands of hours. Cooler running engines experience less thermal expansion and contraction. Piston rings seal better against cylinder walls that aren't constantly cycling between temperature extremes. Oil oxidizes more slowly, maintaining its protective properties longer between changes. Head gaskets last because they're not being cooked from the inside. A salmon guide in the Pacific Northwest has been running the lower thermostat for 3,000 hours. His head gasket is perfect. The factory-maintained engine on the boat next to his needed a rebuild at 2,000. But there's a trade-off. Cooler engines burn slightly more fuel. Moisture can accumulate in the crankcase if the engine never reaches optimal temperature. This modification works best for boats that run long hours at consistent loads. Commercial operators, offshore fishermen, serious cruisers who measure their seasons in thousands of miles. For weekend warriors who make short runs and idle at the dock, the math changes. But for those who push their engines hard, day after day, the thermostat swap is one of the most effective longevity modifications available. It also voids your warranty instantly, because it alters emissions calibration, and that makes it illegal in the eyes of anyone who writes service contracts. The fourth trick involves something even more fundamental than engine temperature. It involves the fuel itself. Since 2007, nearly all gasoline sold in the United States contains 10% ethanol. E10 is the standard. It's renewable, it's domestically produced, and it's slowly destroying marine fuel systems across the country. Ethanol is hygroscopic. It attracts and absorbs moisture from the air. In a marine environment where humidity is constant and fuel tanks breathe with every temperature change, this creates a problem with no good solution. When ethanol-blended fuel absorbs enough water, it phase separates. The ethanol and water sink to the bottom of the tank as a corrosive soup while the remaining gasoline floats on top, stripped of its octane-boosting properties. Run that separated fuel through your engine, and you'll experience lean, burn conditions, detonation, and accelerated corrosion in every aluminum component the mixture touches. Ethanol-free gasoline solves this problem. Pure fuel doesn't attract moisture. It doesn't phase separate. It maintains stability for 6 months or longer, while E10 begins degrading in 30 days. Finding ethanol-free fuel isn't always easy. Some marinas carry it at premium prices. Agricultural and aviation suppliers sell it for off-road use. And here's where the legality gets complicated. Using fuel that doesn't meet EPA specifications for highway or marine use technically violates federal regulations. Sourcing off-road fuel and running it in your outboard may break tax laws in some jurisdictions. But marina owners who've spent decades watching fuel-related failures will tell you the same thing. Every carburetor rebuild, every injector replacement, every corroded fuel pump traces back to ethanol. The boats running pure fuel have clean systems at 15 years. The boats following the rules are replacing components every season. Some rules protect you. Some rules protect industries. Knowing the difference is the first step toward protecting yourself. Beneath the waterline, a quiet war is being fought. It's electrochemical, invisible. And if you're losing, you won't know until it's too late. Galvanic corrosion destroys more lower units than mechanical failure ever will. When dissimilar metals sit in salt water, they form a battery. Current flows. Electrons migrate, and the more reactive metal sacrifices itself to protect the rest. This is why your outboard has zinc anodes. They're designed to corrode, so your lower unit doesn't. Factory anode placement assumes average conditions, moderate salinity, clean marina water. No stray electrical current from poorly wired dock pedestals. But the real world doesn't operate on averages. Brackish estuaries concentrate salt in ways that open ocean water doesn't. Marina electrical systems leak current into the water through ground faults that nobody tests for. Hot climates accelerate every chemical reaction, and factory anodes, sized for average conditions, get overwhelmed. The solution is more protection, additional anodes mounted on trim tabs, jack plates, and transom hardware. A comprehensive defense system instead of the minimum required for warranty compliance. Manufacturers warn against overprotection. They cite hydrogen embrittlement, a theoretical risk where excessive cathodic protection causes hydrogen atoms to penetrate metal and weaken its structure. But marine mechanics who've spent careers underwater will tell you they've never seen an overprotected lower unit. They've seen hundreds of underprotected ones rotted through to the bearings. A mechanic on the Alabama coast put it simply: the zinc is cheap. The lower unit isn't. Add more anodes. The sixth trick challenges something every outboard owner has been taught to treat as sacred: the oil change interval. Your owner's manual specifies 100 hours or 12 months, whichever comes first. This number appears across brands, across engine sizes, across decades of development. It's consistent, it's easy to remember, and it's a compromise that has nothing to do with your engine's actual needs. Factory oil change intervals are minimums. They're calculated to prevent catastrophic failure during the warranty period, while minimizing the number of service visits the manufacturer must honor. They're not optimized for longevity. They're optimized for cost. Marine engines operate under conditions that automotive engineers would consider extreme. Wide-open throttle runs, constant load, salt air ingestion, temperature swings from ambient to operating heat every time you start the motor. These conditions stress oil faster than any dynamometer test can simulate. Experienced mechanics change oil at 50 hours, half the factory interval. They use premium synthetic formulations that cost the same as conventional marine oils, but provide dramatically better protection. And they send samples to laboratories like Blackstone for analysis, letting the chemistry tell them exactly what's happening inside their engines. Oil analysis reveals wear metals, contamination levels, and remaining additive life. It transforms guesswork into data. A $28 test can tell you whether your oil is protecting your engine or slowly allowing it to destroy itself. The seventh trick is subtle, a small adjustment that most owners would never notice, but that mechanics in commercial fleets consider essential. Factory idle speeds are set low, typically between 600 and 700 RPM. This minimizes noise, vibration, and fuel consumption at the dock. It also contributes to incomplete combustion, carbon buildup, and glazed cylinder walls. Raising idle speed by 50 to 100 RPM improves oil circulation, enhances charging system output, and ensures more complete fuel burn at low loads. Every island mechanic in the Bahamas knows this. They bump idle on every outboard they touch, because factory settings are calibrated for sound regulations, not engine health. The adjustment is simple. The benefits are measurable, and it voids your emission certification the moment you touch the setting. After every trip, your owner's manual tells you to flush the engine with fresh water, connect the hose, run for 15 minutes, call it done. What the manual doesn't mention is that fresh water alone doesn't dissolve salt. It dilutes surface crystals. It rinses loose debris. But the ionic bond between salt and aluminum requires something stronger to break. Seasoned captains flush with diluted white vinegar or commercial salt removers before the freshwater rinse. They run the engine during the flush, circulating solution through passages that static flow never reaches. The thermostat, the water pump housing, the hidden channels where salt accumulates and hardens into scale that no garden hose can touch. A headboat captain in North Carolina has been vinegar flushing for 22 years. He's never replaced a water pump impeller due to corrosion. His competitors replace them every season. When the season ends, storage becomes the next battleground. Manufacturer fogging oils are petroleum-based aerosols designed to coat internal surfaces and prevent rust during layup. They work for a few months. Then they evaporate, leaving cylinder walls exposed to moisture and oxygen. Commercial operators discovered decades ago that diesel fuel and automatic transmission fluid leave heavier, more persistent films. They don't evaporate over a 6-month winter. They resist moisture absorption, and they protect surfaces that factory foggers abandon by February. A charter operator on Lake Michigan made the switch 10 years ago. Every spring, his cylinders emerge clean. Before that, surface rust was an annual ritual. The final trick is the most powerful and the most dangerous. Modern outboards are controlled by electronic control units that manage fuel delivery, spark timing, and operating limits. These computers are programmed by manufacturers to meet emission standards, protect against liability, and ensure consistent performance across millions of engines operating in wildly different conditions. But factory calibrations are compromises. They run lean to reduce hydrocarbon output. They retard timing to prevent detonation on low-quality fuel. They impose rev limits that protect lawyers more than engines. Custom ECU tuning rewrites these parameters. It enriches fuel mixtures at high loads, optimizes timing for premium fuel, and removes artificial restrictions that serve no engineering purpose. In offshore racing circles, every competitive boat runs custom calibration. The gains in performance and longevity are significant, but this is not a beginner's modification. Poor tuning destroys engines faster than any other mistake, and altering emissions calibration violates federal law under the Clean Air Act. So why do these tricks remain forbidden? Why don't manufacturers acknowledge practices that demonstrably extend engine life? The answer is economics. Manufacturers profit from parts, service, and replacement engines. An outboard that lasts 10,000 hours instead of 4,000 represents 60% less lifetime revenue. Warranty programs are designed to minimize claims, not maximize longevity. Maintenance schedules are calibrated for corporate liability, not customer benefit. Regulatory compliance adds another layer. EPA certification requires specific calibrations. Any deviation, even beneficial, breaks the legal framework that allows these engines to be sold. Manufacturers cannot recommend what regulations prohibit, and liability culture seals the system shut. Recommending non-OEM products exposes companies to lawsuits. Approved lists protect legal departments, not engines. The mechanics who keep engines running for 8,000 hours understand something the industry won't admit. The manual protects the manufacturer. Experience protects the engine. There's wisdom in the hands of people who spend their lives on the water. It doesn't come from engineering degrees or corporate laboratories. It comes from watching what fails and what survives. From learning what actually works, not what the warranty says should work. That's not rebellion. That's craft. And it's been keeping engines alive longer than any service contract ever written. The choice is yours. Follow the book, or learn from those who wrote their own.